Lecture 10, parallelism of the second order tensor. Actually, the second order tensor will play with these covariant components. Okay. Now this is a curve, this point P in Q. Now, from previous lectures, okay, within this part 6, you just recall the definition, okay, of this partial derivative over here, okay, and this is there, okay, in the previous lecture. This is just to to emphasize second order tensor is invariant. You see, now these are the covariant components. This is a basis vector here. This is basis. There's a space vector, and this is a basis. Okay. Now C lambda is a contravariant component. This contravariant component, it stays on the denominator when you take covariant derivative. So this will behave like a lower index, as we called attention in many occasions. Now, the parallel transport of a second order tensor, okay, are these covariant components over here, which belongs to this space vector, okay, in a curved space with a given connection is a Christoffel symbol, okay, it's called connection. Is described by the covariant derivative. This is a covariant derivative. Attention now, lambda, mi, and nu are lower index. And also remember that this lambda here corresponds to this partial of C lambda. You see, this is in the denominator, okay? This is C lambda, the curve. Now, this condition here ensures that the tensor remains unchanged along a given direction. See? Now this that we call parallel transport. Now, see part 6, lecture 7, okay? Then I derive exactly this left-hand side over here, this side and this side over here. That is there. Okay? So, since we want a parallelism, we set this relation equals 0. I call relation 2. Now, each terms represent this. This is ordinary derivative, okay, of the components of the attention now. These are covariant components which belong to this vector space here, not dual. Okay? Now, this term here, this is a kind of correction, okay? Because when we expand this base here, we will have two terms, okay? If you expand this term here, okay? So this is, we are saying here, this is a correction to the transport in the first index, okay? In this case is mu. And the third term over here is exactly the correction to the transport in the second index, that's nu. Recall that this minus sign over here comes from the fact that we are taking partial derivative of the contravariant basis. It's written over here, and also in the previous lecture is still in the part 6, okay? We see this. And this here is exactly was derived on lecture 7 of this part 6. Okay, equation 2, you see, equation 2 governs how the covariant components t, mu nu, lower indices remain unchanged. That's the idea of parallelism. Okay, as we emphasized previously when we derived the first order tensors, a vector. Okay, now this remain unchanged under parallel transport along a given direction. You see, this is a given direction. Okay, it's important here. Now this is for each curve. Okay, no, is as I emphasized previously. Okay, if you change the direction, okay, it's not a parallelism. Okay, it's not. We don't see parallelism. We only define parallelism on the one direction. Okay, as I emphasized in previous lecture, it's still in part 6. Okay, that's it.